Hello everybody. Today I can prove triangles are similar using AA. We did a lesson a few weeks ago where we had three methods to show triangles were similar. We had SSS, SAS, and AA. The S's meant the sides were in proportion, and the A's meant the angles are congruent because the corresponding sides of similar triangles are in proportion. The corresponding angles are congruent. Now that we're shifting to proofs, when I do proofs, I always prove things congruent. So I can't use the SSS or SAS methods for proofs because I don't prove things are proportions. I prove things are congruent. The only method that has things congruent is AA. So whenever I'm proving triangles similar, the reason is always AA, which means I need to prove two angles congruent. So when we did congruent triangle proofs, we always proved three things congruent. Now we're proving two things congruent. Angles. Always two angles. So instead of, three things and mix the sides and angles, for similars, it's always two things instead of three, and they're always angles. And just again to show you why angle proves triangles are similar, if two angles are the same, and the angles of a triangle add to 180, and I do 120 plus 20 plus x equals 180, and I solve it, I'm going to get 60. And if I do the same thing for this one, again, it's going to be 60. So basically what I'm trying to tell you here, if two angles of the triangle are the same, then the third one must be the same. And a similar triangle are similar triangles are triangles that have the same angles. That's why I only have to prove two pairs of angles the same, because if two pairs of angles are the same, then the third one must be the same as well. So this brings us back to proofs. I think even though this isn't exactly the same, let's just go back to our proof song real quick. 299 subscribers. You could be number 300 right now. Isn't that so exciting? And we're going to have a different song tomorrow for similar proofs, but we're going to listen to our congruent triangle proofs today just to help us with the procedure of how to get our two things congruent.
Theorem. If you get stuck, please make something up.
All right, so let's talk about what we learned in proofs. Again, in congruent triangle proofs, we're always proving three things, but as I just mentioned, for similar, we're only proving two angles. We're going to talk about this stuff tomorrow. To get my two things, I do a mini proof with my givens. Altitude, angle bisector, perpendicular. We also had median, line bisector, and midpoint, but since those deal with sides, they're not going to come up in this lesson. We also talked about parallel lines cut by a transversal. That was our 8 dots. Once we run out of givens, we're going to look for our additional tools. That's not what I wanted to do. We're going to look for our additional tools. Vertical angles. Look for an X, reflexive property when there's a side or angle. Of course, in this example, in this case, it's going to be angles. That's in both triangles. I never talked about Isosceles triangle theorem, so if that does come up here, I'll tell you not to worry about that one. So let's jump right into it. I need to prove two pairs of things congruent, two pairs of angles congruent. They want me to prove that triangle TCA is similar, notice the similar symbol, to triangle TCO. So I need to prove in order to prove similar, I need to prove two pairs of angles congruent. So this one given kind of has two things in one. Altitude TC bisects angle ATO given. So there's altitude. Well, an altitude creates, we'll refer back to this if you need to, two congruent right angles. So where are my right angles? My right angles is where the altitude meets the base. Angle TCA is congruent to angle TCO. I have one pair of angles congruent. I need two. Again, Mr. Schlansky, what happened to three? I need two for similar. Congruent triangles, which we're not doing here, we need three things. For similar, we need two, and it's always angles. Well, the given also incorporated angle bisector. So refer back if you need to. And this is in the front of your packet, by the way, all these notes. An angle bisector creates two congruent angles. I don't know what happened there. An angle bisector creates two congruent angles. So ATO is what's being bisected. T is the vertex of that. So those are your two congruent angles, ATC and OTC. Now that I have two pairs of angles congruent, I can state that the triangles are similar. Triangle TCA is similar to triangle TCO. And the reason always, whenever you're proving triangles are similar, is AA. I have to prove two pairs of angles congruent. I did that right there. Once I have my two pairs of angles congruent, I can state the triangles are similar, AA. Same structure, same procedure as triangle proofs, but this is probably a little bit easier because instead of needing to prove three things, I only have to prove two, and I know it's always going to be two angles. I don't know what that's doing in here. What are all this stuff doing in here? All right. Number 2. I'm always proving well, I'm not always proving anything. It wants me to prove that triangle SCY is similar to triangle NAK. To prove triangles are similar, I need to prove AA. I need to get two pairs of angles congruent. So I take my givens one at a time. CL is parallel to HA. Given. Now parallel we spent a lot of time on. When you see parallel, extend your parallel lines, extend your transversal. If you don't remember this, I made a video on specifically parallel mini proofs, so find that. Parallel mini proofs or parallel definitions, I called this something like that when we initially did proofs, and refer to that. I want to see my 8 dots. Where does the transversal hit the parallel lines? At Y and at K. Which of those angles are the angles of a triangle? That one and that one. I color the inside. Are they both inside? Are they both outside, or 1 and 1? They're both outside, so those are alternate exterior angles. If they were both inside, it would be alternate interior angles. If it was 1 and 1, it would be corresponding angles. So angle SYC is congruent to angle NKA. The reason, if you remember, the parallel is a big one. Parallel lines cut by a transversal create congruent alternate exterior angles. So that's one pair of angles. I go to my next given, that's a gift. Angle CSY is congruent to angle ANK. Given. I want two pairs of angles. I have two pairs of angles, so I did it. I can now state that triangle SCY is similar to triangle NAK. And the reason always for proving triangles are similar is AA. To prove triangles are similar, I prove AA, which is two pairs of angles congruent. I take my givens, I do mini proofs, I dip into my additional tools if I need to, and once I have my two pairs of things congruent, I can state the triangles are similar. The reason always is AA. So I'd like to go over maybe one or two more with you. I guess we can do 6. So it wants me to prove that triangle ABC is similar to ADE. In order to do that, I need to get two pairs of angles congruent. Statements, reasons. BC is perpendicular to AC, given. BC, AC, meet there. That gives me one right angle. I need a second right angle for the green triangle. Well, it gives me another perpendicular. It gives me that DE is perpendicular to AB. Now, if DE is perpendicular to AB, those are two right angles right there. I don't care about all the right angles. I need one right angle in the blue triangle, one right angle in the green triangle. So this is my right angle in the blue triangle. This is a right angle in the green triangle. This is a right angle, but it doesn't help me because it's not an angle of a triangle I'm trying to prove, so I'm going to kind of just disregard that. I know my definition for perpendicular. Again, you can flip back if you need to. Perpendicular lines create two congruent right angles. And this one, angle ACB, is congruent to this one, angle AED. That's one pair of angles congruent. I need two. I'm out of givens. So once I'm out of givens, I go to my additional tools. VRIAS. VR, vertical angles, reflexive property. Vertical angles I have when there's an X. Reflexive property is a side, or in this case, an angle. That would be in both triangles. So let's see which I have here. Do I have vertical angles? Do I have an X anywhere? No. So I'm going to look for reflexive property. Is there an angle that's in both triangles? Well, the answer is yes. Take 10 seconds and try and find it if you don't see it right this moment. Angle A. Angle A is an angle of the green triangle. Angle A is an angle of the blue triangle. So I can say that triangle EAD is congruent to triangle EAD, reflexive property. Now I have two angles congruent. I want two angles congruent, so I can state that triangle ABC is similar to triangle ADE, and the reason always for similar is AA. I prove two pairs of angles congruent, then I state the triangles are similar, reason AA. To get my two pairs of things congruent, again, I'm doing the same thing I did in the triangle proofs unit. You're doing a mini proof with your givens. If you run out of givens, you're moving on to your additional tools. The only ones we talked about are vertical angles and reflexive property. So again, this is 2020. I'm doing this right now. I'm hoping to use this past 2020. Being how it's 2020, and for those of you who've lived through 2020, you know what that means. Number 7 is one that you have not learned how to do. So don't worry about it if it's 2020. If it's not 2020, then yes, you will have learned how to do that. So just giving you a heads up on that for number 7. If you want to look at the answer key and work and figure it out, that's fine. But I wouldn't worry about that otherwise if it's 2020. And that's it. To prove triangles are similar, AA, two pairs of angles are congruent. Once you have two pairs of angles congruent, then you can state the triangles are similar. Your classwork/homework is to finish the worksheet on this. I hope everybody has a great day.